Gravitation, gravitation, gravitation. What is that gravitation? This is the one of the mass has mass m1. This is another mass has mass m2. These two are separated by a distance r. According to the statement, the force is acting, attractive force acting between these two masses, that is F is proportional to the product of their masses m1 and m2. F is inversely proportional to the square of the distance between these two bodies. If I would write a combined this, F is proportional to the m1 m2 by r square. If I remove the proportionality, this proportionality, I will get some constant. So F equals to G m1 m2 by r square. Here G is the gravitational constant, universal gravitational constant. The value of the G is G equals to 6.67 into 10 power minus 11 Newton meter square per kilogram square. Newton meter square per kilogram square. This is the value of the universal law of gravitation. Then we want to know what is the dimensional formula of the universal law of gravitation. So here from this we can easy to write dimensional formula of the force, dimensional formula of the meter square, dimensional formula of the kilogram square. Dimensional formula of the force is m l t power minus 2. So here meter is there, L square by m square. Then here m get cancelled. Then m power minus 1 L cube t power minus 2. This is the dimensional formula of the universal law of gravitation. Sorry, not a universal law of gravitation. Universal gravitational constant. Dimensional. It is one of the important. Right. Now we have, this is the, see, this is the gravitational force F equals to G m1 m2 by r square. This is the magnitude form. But we want to find out we want to get in the form of vector form. So that's why we have to write here F r equals to G m1 m2 by r square. I have to multiply with the unit vector r cap. Then F bar equals to G m1 m2 by r square, r bar by r cap. Sorry, this is the magnitude of the r only. So now we have to write another way. F bar equals to G m1 m2 by r cube into r bar. This is the vector form of a gravitational formula, right? Gravitational force formula. Okay, now we have to know some more information about gravitational force. Gravitational force and electrostatic force, Coulomb force. I think Coulomb force is, if I will take two charges, let us here, this is the positive charge, this is also positive charge. So repulsive force is there. These two are repulse each other. If I will take this is the positive force, sorry, not a positive force, these are the two charges, positive charge and another positive charge, repulsive force. This is the positive charge and another one is negative charge. There exists a attractive force between these two. That means electrostatic force has a two. That means attractive force, repulsive force. But coming to the gravitational force, it has only attractive nature. It has only attractive nature. And we have to know gravitational formula F is directly proportional to the square of the distance between these two masses. Similarly, Coulomb force also, electrostatic force also, square inverse law. So if you notice this is the gravitational force, this is the electrostatic force also, followed by the square inverse law. So here I have to draw the graph bit for the force and distance between the two charges. This equation is giving the hyperbola equation. So we have to draw a hyperbola. It is giving to the rectangular hyperbola according to this. This is the rectangular hyperbola. So along the along the y axis force, x axis display square of the distance. So according to this, we got a, according to this equation I drawn this one. Okay, this is regarding about gravitational force and electrostatic force. Gravitational force is a conservative nature. What is the conservative nature? The work done by it throughout the path along the closed path is zero. The total work done by the along the path is zero. That is called the conservative force. Gravitational force is a conservative force, right? Gravitational force between the two bodies does not depends upon the properties of the medium. So this is regarding about the gravitational law and formula and vector form of a gravitational law and dimensional formula, and a little bit comparison between the electrostatic force and gravitational force. Thank you.